concept that we have for you today is functions. We're going to look at this idea in three different ways. We'll first start by looking at functions through ordered pairs and tables. Next we'll move on to looking at them graphically. And finally we'll look at functions with equations, dealing with function notation and things like that. So what is the definition of a function anyways? It's a unique relationship where each input has exactly one output. And we usually denote our inputs and outputs with x's and y's, but it could be other variables depending on in your case or your scenario that you're dealt with. The first coordinate of your ordered pair is known as the input, and the second ordered coordinate of your ordered pair is known as the output. Those are also known as your independent and dependent variable. And when a tutor or a professor is trying to describe the concept of a function to you, they might draw this function machine, as you could see here. So I thought I might draw it as well. So just like the definition, you input something into the function and it spits one output out. So if this function were to spit two things out of it, it wouldn't make sense with the definition anymore. So I just thought I might put that up for you. Now, I wanted to give a real world example of functions, just to get an idea of how the definition plays in. So here I've constructed a linear equation. This is regarding a balance for my rent. So here I have the balance starting with $2,000 and I'm paying $400 for rent every month. So here you could see that my input is M and my output is B. So like I said, depending on the case that you're in, these variables could change. We don't always use x's and y's. So right from the beginning, I could see that I have $2,000 in my bank account. After a month has gone by, I could see that my balance drops to $1,600. After 3 months, it keeps decreasing. Now it's at $800. And after 5 months, I could see that I have no balance in my bank account anymore. So from this, I could see that knowing a given time, I could predict my balance corresponding to that. And going back to the function definition, for this to make sense, I could only have one balance corresponding to a given time. That is if I had one balance. I mean, if I had a checking account and a saving account, I could have different balances. But here we're just saying we have one balance. So for me to have two balances at a given time, that really wouldn't make sense. And as we said earlier, your output is the second coordinate of your ordered pair. So we could see that our output is B. And that's also known as the dependent variable. So your balance depends on the month, and when a certain variable depends on another one, we say that it's a function of that variable. Okay, let's look at functions with ordered pairs now. As you can see, I've listed some ordered pairs here for you, and I did want to mention that there's a faster way of determining whether something is a function or not by just looking at an ordered pair, but since this is our first example, I just wanted to go more in depth and show you more detail. So we know that the input is the first coordinate of our ordered pair. So our inputs in this case would be these numbers here. So I'm going to list those out vertically for you. And we also know that our output is the second coordinate of our ordered pair. So these numbers would be our outputs. And notice that the 4 repeats, the 1 repeats, and then we have just a 0. Okay, now let's just draw some arrows leading the inputs to their outputs. Let's see here, the -2 goes to 4. The -1 goes to 1. 0 goes to 0. The 1 goes to 1. And then the 2 goes to 4. Okay, so looking at this, I could see that every input has one line coming from it. So that tells me that it's only got one output. So it matches the function definition. So I could tell that these ordered pairs listed here, by looking at them, I could tell that it's a function. You might have also noticed that looking at our outputs, 2 arrows are leading to it, which might have you wondering if it's a function or not. But the function definition says for every input, you could only have one output. It doesn't say that you can't have the same output coming from different numbers. So by this we could tell that this is a function. Okay, still moving on with functions, looking at functions with ordered pairs. Here's a second example that I've provided here for you. Again, let's go ahead and mark our inputs, which are the first coordinate of our ordered pairs. So those would be our inputs, and let me list those for you. We got a -3, a 0, a 3, and then the 0 repeats, so I'm not going to write that one again. Okay, the outputs now. We know that's the second coordinate of our ordered pair, so those would be our outputs. Let me see if anything repeats. The 0 repeats, so I'm just going to write that one once. We have a -2 and then a 2. Okay, let's do our arrow drawing that we usually do. We're pretty good at this by now. So let's see, the -3 goes to 0. The 0 goes to -2. The 3 goes to 0. The 0 goes to 2. Okay, let's investigate this time what's going on. If you looked at the other video, there was only one line coming from each input, which meant that it had one output, which met the function definition. Here I see 2 arrows coming out of 0, which means it has 2 different outputs. 0 gives you -2. 0 also gives you 2, which doesn't match with the function definition. The function definition says for every input you can only have one output, but here I could see it's giving me 2 different outputs. So by that, simply we could tell that it's not a function. Okay, still working with functions through ordered pairs and tables. Since we did so many ordered pairs, I decided to make a table for you guys. Now, we're not going to go ahead and do that whole arrow thing anymore. As I pointed out earlier, there is a faster way of knowing whether something is a function or not given an ordered pair or a table. So just given these values, looking at this table, if you want to do it a faster way, you could just jump to the inputs and just see if you have any duplicate or anything repeating from your inputs. As you can see here, there's no inputs that repeat, so you could just tell that it's a function by that case, because the function definition says every input has exactly one output. So if you don't have an input repeating, you don't even have to worry about that. But for example, if I wanted to change this 1 to a -2, then I would have to consider if it's a function or not, because I have 2 inputs repeating. Then that would grab my attention. And in this case, an input of -2 gives you 5, and an input of -2 gives you 1. So I'm getting 2 different values coming from the same input, which means that it's not a function. So that's a faster way that you could approach these problems.